Every action has an equal and opposite reaction. A couple of things to mention about this. So when I talk about the action, when I talk about this reaction, it's always on the opposite object. And the opposite direction. So when you say has equal and opposite, I mean opposite object and opposite direction. All right, let me talk about 14 here. So 14 is a tricksy one. So in number 10, we said they're usually equal because the net force is 0, but they're not always equal. So most people think that the reason they're equal is because of Newton's third law. Every action has an equal and opposite reaction, right? So I get pulled down by gravity, and the normal force pushes up on me. Those are equal, they're the same value, and they're in the opposite direction. So it seems like it should be the same thing. But the reason they're not the same thing is because they're on the same object. The Earth is pushing up on me with normal force, and the Earth is pulling down on me with gravity. They're both on me. Okay? And it can't both be on me because it has to be an opposite object and the opposite direction. So normal force is not equal to 0 because it's the same. Like, they're not equal to each other because Newton's third law. They're equal to each other because the net force is 0. So, what is the equal and opposite force then? Well, it has to be the opposite object, and it has to be the opposite direction. So if I'm the object getting pulled on by Earth, then the opposite would be the Earth getting pulled on by me. So the answer to number 14, what's the equal and opposite force to gravity pulling on me, is me pulling up on the Earth with gravity. And I know that sounds absolutely bizarre, but that absolutely is the equal and opposite force. The force that I pull up on the Earth with is the exact same as the force the Earth pulls down on me with. Okay? I did this example last year. So if I stand on a desk and I jump off, I literally will make the Earth move because it's pulling me down, I'm pulling it up. However, I won't... I know. But you didn't see the Earth move, which actually is the better question for 15. It's the same question. Why doesn't the Earth move? I mean, like, it does, but it doesn't. Right? Like, none of you fell out of your desk because the Earth moved so fast from me jumping. I appreciate how much you think I weigh, but it's not that much. Vaughn, what do you think?
It has the same force, but it has more mass, so it has to have less acceleration.
Exactly. Let's jump to Franchet's equation, right? A equals F net over M. So they have the exact same force. F net is the same. But they don't have the same mass. So because, did I really just leave the A off that equation? Oh my gosh, goodness gracious. Thanks. I just totally forgot the A. If this is the same for both objects, but the mass is not, then the acceleration isn't either. And my mass, what did I calculate mine to be? My mass is like 60-ish kilograms, something like that. The mass of the Earth is 5.98 times 10 to the 24th. So the Earth's mass is a trillion billion times more than mine. I know. So obviously, it doesn't move when I move because it just has so little force. If you went into space, you could throw the Titanic, but because its mass is so big, you wouldn't see it move. You would see you go flying backwards, and the Titanic wouldn't look like it does anything, even though technically you're throwing it. When I jump, I'm technically pulling the Earth, but because its mass is so big, we don't see it. Okay? So me pulling up on the Earth with gravity, that's the reaction. So why is it that those things aren't the same? they're not the same because the masses are so different. Meaning A is different.